Okay, so we're going to be looking at some box plots first, and I just thought I'd look up box plots on Google, and you see lots of different examples of box plots. These are all box plots, and let's take a look at Wikipedia. So let's see if they have a big one. No. Well, anyway, here's a box plot. Here's another. So what a box plot shows you is it's supposed to sort of try to show you the range of the data. So this is like some experiment, and the speed of light. Okay, so this is the speed of light. So in this experiment, I guess they measured the speed of light many times. Let's suppose they measured it like 100 times. So some of the times they measured it was up here, and some of the time it was down here, and maybe some of the time it was down here. So 700, whatever this is, kilometers per second, 800 kilometers per second, so some of the time it was. So because of the way we measure things, it's not so accurate, and so we might get different numbers for different measurements. So this is supposed to show you kind of the range of measurements. So sometimes we got it down here. Sometimes we might have even gotten it down at 700. We might have gotten it at 1,000 or even more. Actually, sometimes even up here. That's what the box plot is supposed to show you. Now, this line here is supposed to show you the median of the data. So that would be the median of all the 100 measurements. What's the median measurement? Okay, so it looks like it's about 950. Okay, so I'm not going to explain what the median is, but I think you know that. And this means this value here, this height here, which is about what, 980 or something like that, is the 75th percentile. That means that 75% of all the measurements that we made were less than 980. Some of them were above. 25% of them were above. 75% of them were below. This line here, that is this height here, which is about 855 or something like that, means that 25% were below this line. So 25% were below whatever, 855. So that means that between here and here, this is 75th percentile, this is 25th percentile. It means 50% of the measurements were in here. So this is supposed to show us, well, the generally we can say that the measurements were in this range from here to here, whatever that is, as we said, 980, 850, or 855, whatever that is. Generally, the measurements are in this range, because that's like 50% of all the measurements were in this range, and the sort of middle 50% were in here. This line up here, I'm not sure exactly what this is. It's not the highest measurement, but it's like, I don't know, 1.5 times the standard deviation from here or something like that. But anyway, when you go out to here and you go out to here, that's supposed to encompass almost all of the measurements. And if there were any outside of here, you might have a little dot out here to indicate there was one down here. And usually that kind of measurement we'll refer to as an outlier. Okay, so there was one outlier. It was about 650 or whatever that is. Okay, so this is supposed to be like basically the full range from here to here. And if there's anything outside of there, here you can see there's some outside, but they're basically, we expect that things are going to fall between here and here. So that's what we mean by a box plot. And as you know, there's a box plot function in R. So he says the box plot shows the distribution of attendance across days of the week. Let's just check that. So unfortunately, in the way that I scanned this, you can't see the median line, although you might just see it here or here, but you can't really see it. So anyway, but regardless of that, this is the box plot for the Monday data, for the games that were played on Monday, the attendance for the games that were played on Monday. So we can see that there was one kind of outlier that was around 52,000 or 51,000 or something, or 50,000 people attended. But generally on Monday we can see that the middle range was between here, which is about 37, and here, which is about 33 or something like that. So that was the basic range of attendances on Mondays. On Tuesdays, we can see it was much higher. The basic range was close to 55 and down to about 44, something like that. So it was considerably, the main attendance for Tuesday was higher than it was for Monday. And Wednesday we can see it's lower than Tuesday. And Thursday we can see that it's kind of very spread out. So it means there was a lot of variability on Thursdays. Like sometimes they had quite low attendance and sometimes they had quite high attendance. Or you can of course all go all the way up to here. And here, and here, and here, and so on. Now, as I just said, the length of this box indicates the spread or the variability of the data in that on that day. So we can see that Thursdays was very variable, but Monday was not variable at all. It was basically a narrow range of values. So that's what figure 1 shows. Figure 2 shows attendance by month. So that will be good, interesting to see. And he says box plots like these reveal the overall values of the data with boxes covering the middle 50%. That's what we just said, or so, of the distribution, and with the center line representing the median. That's the line that you can't really see in my scan. The dotted lines, or so-called whiskers, those are the end lines, extend to the more extreme values in the distribution. By looking across the box plots, we can make comparisons across the distributions of attendance by day and month. Okay, let's check it out. So what he's saying is that we might look at this kind of box plot and maybe it will give us some information. And of course this does give us some information. For example, one thing we can see is that Tuesdays, generally the attendance is much higher than, say, on Monday, or and so on. We can see that on Thursdays the attendance is very variable. So in this case, we might look for some other factor which determines why it would be low on Thursdays versus why it would be high. Is there anything we might look for? So that's why these graphs can be interesting, because it leads us to other questions. It leads us to, well, I wonder why this is so variable, or I wonder why this is so high. So we can see this stuff and then we can ask questions. So that's the purpose of the exploratory graphics that he's doing here. Another thing is that we can see that definitely the data varies by day. So that means that we want to include day of the week as part of our prediction of what the attendance will be. If these were all the same, if on Monday it looked exactly the same as Tuesday, is the same as Wednesday, and so on, then that would mean that there's no point in including day of the week in our analysis, because it doesn't separate the data at all. We can't say, oh, on one day it was this way and another. It doesn't do that at all. So there would be no point in including it in like what we're going to do, like in terms of making a prediction, in terms of making a regression model. But here it suggests that it definitely varies by day, and so we want to include day of the week as a variable, or in fact we're going to have to include all of these as separate variables, but you'll see that later. But anyway, we want to include day of the week as a variable. And very quickly, for this one, this is what? The same y-axis attendance, but this is the months. And again, we see a lot of variation over the months in terms of attendance. And so it also leads us to want to include month as a variable that's going to be used in our prediction. And also, as I said, we might say, well, why is it that it's higher in June, and why is it that it's lower in October, and why is it so variable here and not variable here? So these kinds of pictures help us to ask good questions.